Scientists all around the globe were watching a solar storm hurl itself to Earth. The concern, a huge disruption with power grids, satellites, air travel, and GPS systems. But as meteorologist David Chanley explains, this time the storm weakened.
The sun does more than provide us heat and light. It sends us energy, and oftentimes sunspots like these can produce powerful and potentially crippling electromagnetic storms.
The sunspot cluster, it's huge. It's like 40 Earths across.
And this solar flare is sending a magnetic particle storm to Earth. Astronomers like Fernbank Science Center's April Witt are tracking its intensity and potential impact to hundreds of satellites circling the globe.
We have stuff out in space that 50 years ago wasn't a problem. Now, we're really dependent on satellites, GPS for positioning, telecommunications satellites.
The concern was the disruption of the electromagnetic field, but the power of the storm did not hit the level that it was forecasted. I've seen no reports of communication breakdowns. Here's why the solar flare did not have a huge impact on North America. Here's the sun. It takes several hours for that energy to make its way to Earth. When that happened, the main energy was on this side of the globe. We were on the backside. It was in the middle of the night. It was like North America was turning its back on all the solar particles, protecting us. A second, smaller solar storm is arriving now, and scientists with NOAA are still monitoring. Astronomer Witt tells me this pulse shouldn't cause issues, but might paint a nice picture.
Energy is smacking into that and sort of bending the shape of that magnetic field. It can create really nice auroras, northern lights, in particularly high latitudes, possibly even as far down as like North Georgia for us.
But it appears with this less intense solar storm, auroras like these will stay well north of Georgia. However, stay tuned as we're entering a very active solar season.